Dear students, like and subscribe my channel. On my channel you will get 3 subject notes specially for this 4 sem students. You will get ADA, then 5th semester TOC and 6th semester compiler design notes. Your subscription is important. This is Warshalls algorithm. In Warshalls algorithm you can find transitive closure for the graph. In this Warshalls algorithm, this is dynamic programming problem. In this dynamic programming, each step solution is overlapping, and within this Warshalls algorithm we can write either 0 or 1. If edge is there, with or without intermediate, write 1, otherwise write 0. Initially this graph is converted into matrix. If graph is given, then convert this graph into matrix, and if matrix is given, convert that matrix into graph. Right, first this is adjacency matrix, and if graph size, here total number of vertices is n equal to 4, n equal to 4, then matrix is 4 into 4, there are 4 rows and 4 columns. This is adjacency matrix. Convert this adjacency matrix in this adjacency matrix. First x, x2 x edge is there? No. This is x to x is 0, x to y 1, x to z 1, x to w 0. By default this is x, y, z, then this is w, x, y, z, then w, or you can take w, x, y, z. Meaning is same. Okay, matrix will get different. Y to z, only one edge is there. Y to x 0, y to x 0, y to y 0, y to z 1, y to w 0. The next z to w, only one edge is there. Z to x 0, z to y 0, z to z 0, z to w 1. Then w to x, only one edge is there. W to x, w to y 0, w to x 1, w to y, w to z 0, and w to w 0. This is adjacency matrix. In step 1, or we can assume this is step 1, and then we can start step 2. We can write any. This is step 2. Step 1. In step 2, vertex x means k equal to 1. K equal to 1 means 1 as a intermediate vertex. Means vertex x as vertex x as a intermediate vertex. Means using x we can take transactions. Using x we can take transactions. Means here r to the power 1. R to the power 1 means 1 as a intermediate vertex. If if x as an intermediate vertex, x itself as an intermediate vertex. If x itself as an intermediate vertex means this first row will get same values. Means 0, 1, 1, 0. Next y to x. Is there any edge? Y to x, there is no edge. Means this row also will get same value. 0, 0, 1, 0. Z to x, is there any edge? No. Z also will get same values. Next w to x, yes, edge is there. If w to x is edge is there, then this row maybe will get different values. Means first w to x is 1, then w to x, x to y we can take transition, w to x, x to z also we can take transitions. Only you cannot take w to w, right? W to x, w to y, w to z, and w to w is 0. This is vertex x as a intermediate vertex. Next, step 3 must k equal to 2. If k equal to 2, then vertex y as a intermediate vertex. Vertex y as intermediate vertex. If y as an intermediate vertex means x plus y both are intermediate vertex, and within this we have to find r to the power 2. There are r to the power 2. There are 2 intermediate vertices. Now we check x. Y is intermediate vertex means x to y edge is there. If x to y edge is there, then this row, first row will get different values. X to y, first x to x 0, x to y, y to z is there, but already x to z is there, right? Must x to y 1, x to z already 1 is there. X to w you can take transaction, no, this is 0. The next, y itself as a intermediate vertex. Y itself as a intermediate means this row will get same values, right? Next, from D, z to x edge is there, no. Z to y x is there, no. Must z row will get same values, 3 zeros 1. The next, y as an intermediate vertex. From w to x, x to y, y to z already we can take this transaction we can take, but already w to x, x to z already 1 is there. Means this one, this row also will get same values, right? This is r to the power 2. Next, r to the power 3. R to the power 3 means there are 3 intermediate vertices. If there are 3 intermediate vertices, check here. Next step, r to the power step 4. In step 4, k equal to 3, and if k equal to 3 means vertex z as a intermediate. Vertex z as a intermediate vertex. If vertex z is an intermediate vertex, then here r to the power 3. Within this r to the power 3, vertex z as an intermediate vertex. If z is an intermediate vertex, then you check k equal to 3. K equal to 3 means z is an intermediate vertex. If z is an intermediate vertex, in previous here x, x2, y1, x2, x2, y1, x2, z1, x2, w previous is 0. Means if z is an intermediate, x to z, z to w, we can take transaction. Means this one will get 1. First row 0, 1, 1, 1. Right. Next, second, y as z as an intermediate vertex. If z is intermediate vertex, y to first, y to y you cannot, y to x you cannot take, y to y, y to y also you cannot take, y to z 1 is there, y to w this one you can take 1. Means y to z, z to w. Means 0, 0, 1, 1. The next, z itself as an intermediate vertex. If z as itself as an intermediate means this row will get same values, 0, 0, 1. Next, w as a z as an intermediate vertex. If z as an intermediate vertex, you check here first 3 1s are there, only w to w. If z as an intermediate vertex, you can take w to w. Means this is all are 1s. 1, 1, 1, 1. Right. Next, vertex step 5 must k equal to 4. Total number of vertices is 4, and k equal to 4 means you can stop. This is last step. vertex W as a intermediate vertex. If W is an intermediate vertex, now you check here x to x you can take, x to z, z to w, w to x you can take. This one you can write 1. Next y, y to x, y to z, z to w, w to x. Yes, you can write this one 1. Then next y to y, y to z, z to w, w to x, and x to y you can write 1, right? Next this 3. This is z, z to x, z to w, w to x you can take. Then z to y, z to w, w to x, w to y you can take. Then z to z, z to z you can take. But here this last r to the power 4, this matrix will get all rows 1 1 1 1 1 1 1. Here this is y to x, y to y. Must 1 1 previous 2 1s again. The next z to x, z to y, z to z, z to w already 1 is there. Now this is all are 1s, and d row already 1 is there. This is last step. You have to solve up to this. Dear students, like and subscribe the channel.